Hi everyone, I'm Jandy Carl again here, and today I will show you how the activity 3 was done. So the title of our activity today was Activity 3, Longshan Compound Motor Connection and Cumulative and Differential. So here, as you can see, as the procedure, the we have our data acquisition, main power supply, DC generator, and prime mover. So as you can see, I also connected the the lo- the connection already. I just follow the instruction on the given manual. So I will explain it to you how I connect it. So first, I just connect the E1 into the E7, and again another E1 to the positive 7. E1 into the I1 positive, and the current one into 9, and I mean 3, and the 3 is connected into 5, and 1 is connected to the 4, and the neutral here is connected to the 5. 5 and 6 is connected in this area. So the procedural one, turn on the main power supply and adjust the voltage knob control by not exceeding the nameplate rating of the motor. So let's start with 50%, and I will record the nav, the voltage one, the current one, and also the RPM. I will flash it on the screen later. So let's start flashing. So I set it into 50% now. As you can see here, 50%. This one. And of course, we have our metering, we have our voltage and current one. So let's start this. Let's on this. Select on and on. Here, um, wait, let's adjust this. Digital apply, okay. Here, as you can see, we have our data here. We have our voltage. The nav percent was 50%, and the voltage one is a 71.29%, and our um, current one is 0.808 amperes. So our scaling here is about 8 amperes, and then about here is our scaling here is 20 volts. So we can adjust this. Oh yeah, only 20 volts. Sorry. So now we just proceed to the next question, as the question was asking about observe the shaft of the motor and the dynamometer. In what direction does the motor rotate, clockwise or counterclockwise? As you can see, it is rotating counterclockwise. Okay. So next, turn off the main power without changing the voltage knob. Interchange the connection to the shunt field winding to the long shunt differential DC motor, as shown in figure 2. Now, I will make the connection into long shunt differential DC motor, because this is the long shunt cumulative DC. This is cumulative, and I will change it into the shunt differential. Shunt differential DC motor. So let's turn it off first. Turn it. So hello everyone. As you can see, I already changed the wiring or the connection into the differential DC motor connection. Now, according to the procedure, let's turn on the main power supply for 4 seconds and turn off the main power supply after 4 seconds. And the question what we need to answer is, what is the difference between, what did we observe and what do we think if we let the motor run continuously? So let's test what will happen if we run it continuously. So remember, we need to turn on 4 seconds and turn off it after 4 seconds. Okay, so let's start. Just off in here, here, and here. 2, 3, 4. Then we need to close it out. That and then like that. So what do you think will happen if we um, run the motor continuously? So after observation in a long shunt DC motor connection, we observed that the motor tend to become unstable because the series of field opposes the shunt field. As the load increases, the magnetic flux decreases, causing the motor to rise instead of decrease. This behavior makes it difficult to control under varying loads and may proceed irregular operation. If the motor is allowed to run continuously in this connection, the speed may increase excessively, as we show in the experiment, especially when the load changes suddenly or became lighter. Continuous operation can lead to overheating or excessive vibration or for efficiency and possible damage to the armature and windings due to overspeeding. Because of the unstable characteristic, differential compound motors are rarely used in practical industrial application. So the next question was, what is the difference between the two conditions? So the difference between the long shunt cumulative DC motor and the long shunt differential motor is the long shunt cumulative, the series field aids to strengthen the shunt field, while this long shunt differential motor weakens the shunt field. The long shunt DC motor, the magnetic flux increases when the load increases, while the differential DC motor, the flux decreases when the load increases. The motor speed may increase in differential DC motor, which is dangerously with the load changes, where the motor in cumulative develops higher starting torque and stable operation. So overall, in summary, cumulative compound provides stable and stronger motor performance, while the difference compounding tends to create unstable speed characteristic due to the opposing magnetic field. So see you in experiment number 7.